Hi, I'm Chris, and we're going to take a look at another KSP problem for chemistry. So in this case, if we take a look at the reaction shown here, we have calcium hydroxide dissociating into calcium 2+ ions and hydroxide OH- ions. Now what's important to note is that when we go to figure out how much of each is being formed, if you haven't seen this before, you might want to take a look at our earlier example. But if you have, then what you want to appreciate about this is that here we're adding X amount of calcium ions. And calcium has a coefficient of 1, so that's where we get the plus X. But for the hydroxide, we're forming 2 of those for each calcium hydroxide that dissociates. So this will be a plus 2X. So you're going to have X and 2X as your equilibrium amounts of each. Now for your KSP expression, as we saw before, is still the concentration of products times each other. But we're going to take a look here at what happens with your coefficients. So because the OH- has a coefficient of 2, that means the exponent will be 2 in the expression. So your KSP will be Ca2+ times OH- squared. And when you go to calculate that value, the KSP for calcium hydroxide is 5.02 times 10 to the negative 6. And that will equal, and here's where some people mess up a little bit because they just automatically plug in X for both. But remember, you have to take a look at what you actually have at equilibrium, what you actually have going on in your solution. So for the OH-, we're going to plug in 2X. So that 2 for the OH- kind of counts twice almost. It's going to affect the value that you plug in here, and it's going to impact the exponent. So when you go to solve for the molar solubility, which is X, then this is the expression you come up with, and that will give you 5.02 times 10 to the negative 6 equals, when you multiply that all the way out, you get 4x cubed, and then you can divide both sides by 4. 4 goes into 5.02. It's going to be around 1.25 and change. We'll just call it 1.25 times 10 to the negative 6 equals x cubed. And then from there, to solve for x, you would take the cube root of both sides, and that would give you the value of x, which would be your molar solubility of calcium. Now, if you needed to find out the specific concentration of OH- that you were dealing with, you'd have to just double that value. So if you'd like to take a look at each of those answers, you can confirm the numbers that you came up with and make sure you plugged it in correctly on our website by clicking the link shown here. Otherwise, please stay tuned for more of our chemistry videos in dealing with KSP and other properties of solubility. Thanks for watching.